So now we have defined entities and attributes and relationships. So we're ready to do the first form, normal form, which is create tables when there's a one-to-many or many-to-many relationship. And in the list that I created, there's one many-to-one and two many-to-manys. Many-to-ones don't apply to the first form, which is why the hotel information stays inside the reservation table, okay? So I'm gonna type reservations table with reservation ID, check-in date, checkout date, and the hotel information stays. And reservation ID here is primary key. Our second table, since we have a many-to-many relationship between reservations and guests, it's going to be a separate table. So guests is going to have guest ID as a primary key. So notice that I didn't put guest 1 and guest 2 inside this table because the purpose of the first normal form is to address repeating groups of values. So guests is one example of that. And I'm gonna uncolor this and name that table 2. And do we have a table 3? Yes, because guests and rooms have a many-to-many relationship. So I add colors. So these tables are not connected together. So remember, reservations and guests have a many-to-many relationship. So if it's a many-to-many relationship, in the first normal form, okay, we're not doing the second form yet. In the first form, you have to put a foreign key inside one of the tables. And it's really up to you, but I think the better way to do it is to put reservation ID inside guest table. So I put reservation ID as a foreign key inside guest table. And guests and rooms have a many-to-many relationship. You could do it either way, but I would put guest ID inside rooms here. And don't forget about your relationship arrows. I'll create something that resembles a line.
See if this works. So let's connect it with this. No, that also doesn't work.
So I will draw a really ugly arrow. Sorry about that. But this is how reservations and guests are connected. And you also want to connect guest ID, the primary key and the foreign key together. Make it different colors. So we're almost done with the first normal form. Because remember, I also said address inefficient attributes. So one example of an inefficient attribute is like when you have guest 1, room 1, guest 1, room 2, guest 2, room 1, like that's why we create all these tables. But there's also an issue of non-atomic attributes, like let's say name, the guest name. Imagine we want to query this database and we want to return all guests' first names. Could we do this if we only have guest name? I guess if you just do some coding, but that's why we're doing normalization to make database as efficient as possible. So I'm going to break the name down into first name and last name. Now, If you want, you could also break down the address. The address attribute has the address field, the city, the state, and the zip code. So what if you wanted to return all the zip codes, but it's part of the address, so you have to do some shenanigans to find the zip code. Hotel address, hotel city, hotel state, and zip code. All right. So we have addressed all inefficient attributes, and we have completed the first normal form. Yay. So let's copy over all these tables. So in a second normal form, you want to look at many-to-many relationships again and create even more tables. In this data set, we have two examples of many-to-many relationships, reservations and guests and rooms. So that means we're going to create two more tables. So table 4 is going to be reservation guests. And table 5 is going to be guest rooms. So why do we create the extra tables? It's because some of the attributes are going to repeat again. Like, let's say different reservations were made by the same guests. So the reservation ID is going to change, but all of the guest information will stay the same. You will see it over and over again. So the way to address that is to create another table, and let's call it reservation guests. So we're going to put the reservation ID here and guest ID here. Same thing about guest rooms. The same room could be occupied by different guests. So guest ID changes, but the room type and room price for the same room stays the same. It will just repeat over and over again. That's why you have a guest room table, which has guest ID and room ID as foreign keys. Foreign keys / CPK, I should say. Same thing about this. Let me format this. So now the reservation relationship remains, but oh no. So we get rid of this relationship because reservation ID now is connected to the reservation ID foreign key inside reservation guest table.
So something like this. And I'm going to connect the guest IDs here, and I'll get rid of this relationship and delete this attribute.
Yeah, sorry for the ugly drawing, but now we've shown all the connections between tables, and we're done with the second normal form. Finally, in the third form, you want to look at many-to-one relationships. And there's only one. There's a many-to-one relationship between reservations and hotel, because there's only one hotel in this database. So that's what we do in the third form. We create our final table. So let's create table 6. Finally, hotels get their own table. Oops, I colored these by accident. And we take out all these attributes from reservations table. And let's add a connection between hotels and reservations and also fix all these arrows. So I'm going to add a hotel ID foreign key inside reservations as a way to connect those tables. Here we go. You can definitely do a better job at drawing lines than me. But this is the complete normalization process. So the purpose of normalization is to eliminate redundant attributes, eliminate complexities. And notice I didn't say the word dependency, but what we did in the second form was address partial dependencies. The reservation ID can change in this table, but the guest ID, if the guest ID is the same, then all this information is going to be the same as well. All this information only depends on guest ID, but not reservation ID. Same thing in a rooms table. If room ID is the same, then room type and room price are also the same, even though guest ID could change. That's why we created those two extra tables to address that. So that's called a partial dependency. I also didn't mention transitive dependency, but what we did here, taking out the hotel information and putting it in a separate table, we did that because remember, we said that there was a many-to-one relationship between reservation hotels, which means it's just one single hotel, which could have multiple reservations. So it doesn't really make sense to keep it inside reservation table. The important thing here is to not to create the hotel table too early, because if you did it in the first form, because remember, we identified 4 entities, including hotel. That's why some people would have thought hotel should be its own table in the first form. But we are only creating tables that have either a one-to-many relationship with the main entity, which is reservations, or many-to-many, which is what we did here. And hotel doesn't qualify for that, so that's why it remains inside reservation table until the third form. So there you go. This is your complete normalization process. Good luck with your normalization assignment and team project. And let me know in the comments if you want me to make any other videos about SQL, database design, or anything else. Thank you.